So I'm putting it in the code. Two students for sure I'm not seeing today here. No excuses and nothing. I'm gonna send an email. Um, then that other than that, a few things about the class. I saw everybody submitted homework number one. That's great. Homework number two, I'm gonna give you hints today, which I'm expecting you will submit by Wednesday. What is the when is the deadline? I forgot now. 9th? Today is the deadline for homework number two. I didn't give. I told you Friday, right? Yeah, that's what I was planning. So Wednesday, because I got to talk a little bit about homework number two. There's some challenging problem over there, right? So maybe we should be talking about them, okay? And Wednesday you can submit it. There's a new homework number three. Uploaded it over there, okay? So the homework number three, I haven't started any topic like specifically regarding homework number three. I don't think it's a good idea to put a deadline for homework number three this week. It should be on next week Wednesday, I guess. So sorry, not Wednesday. Next week Monday. Let's go for Monday homework number three because that will be week 5. Don't want to push too much. Homework three. I have that topic covered today. Theory. That's the agenda. Okay. This tangential and normal acceleration. You heard about the tangential and normal acceleration before from physics class? Okay. You heard about radius of curvature? There's a second order differential equation you got to solve to get that value that can be used to find the normal normal acceleration component. We'll see. Those are the agenda. Okay, I'm just trying to warm you up on that. What is happening? Okay, so that's the agenda theory wise. And math was I do have a math. Let's shoot for that. But before even that math, I think I'm gonna talk a little bit with the homework. Okay, then time allows, then I'm gonna go to the math. Okay, so that's the plan. All right, so let's start. The recording obviously is started, and then that's the math I was talking about it. I was talking about the theory. So that's the theory. Okay. So remember, I was talking about that, right? Normal and tangential components. Okay, normal and tangential components of what? This is AT means tangential, and means normal. Acceleration. Okay, let me write it. Acceleration. Now here's the thing about the notes. Now, see, from for your textbook, I have some PPT uploaded in Brightspace. I don't know if you have checked it. Okay, there are these class lectures that you are seeing. These class lectures plus pretty much everything on that chapter on that book is over there. Not necessarily I covered everything, but this is for your reference. Like you're seeing it here, you're taking class not all fine and dandy, but you don't have any of these materials, right? Whatever I'm showing in class, I'm not giving you a printout. So these are digital copy in Brightspace. So I would encourage you to please take a look on that Brightspace. I can show it to you again if you want, but everything is in Brightspace. Okay. So, just want to give you a heads up because I can't share my OneNote. You know that. All right. So there's these objectives and these in-class activities. You'll just simply ignore that. Okay. I'm not gonna do that. As I said, like my agenda would be go through a little bit on this and homework hints, possibly math. So applications where this normal and tangential component of accelerations are applicable. As you can see, these are the highway interstate, like this butterfly kind of a thing. Like for circle, obviously when car moves around with a constant velocity, even though it has a constant velocity, you're gonna always feel some acceleration towards the center. You know that, right? Centripetal, centrifugal force, those things you remember. All right. So I mean, obviously, if you'd like to explore more on this kind of complex thing, they have the description here. I don't want to read through it. If you want, I can go in detail, but one slide can very well take 10 minutes. We won't be keeping up with our scheduled agenda. Okay, so you understand the application. I'm just highlighting it. Okay, anytime you're seeing, you have circling this next one as an example here. A person is in swing. Okay, a child in that case obviously the child is following a pendulum shaped motion, right? In that case it does have a normal component of the acceleration because of the normal force, centrifugal force, right? And because of the movement there is a tangential component of that acceleration field the same way. Otherwise, that swing can't move. Okay. So the detail will be learned. Bottom line, these are some applications where you can use these equations, whatever we are learning today. Any question? It's good? All right. So the application goes on. As you can see, there is a roller coaster, right? It's the same thing. Anytime the roller coaster is coming down, you're going to feel like a little bit weightless because of that curvature. And you need to know the acceleration components, normal and tangential. It's good? Any question? These are just the application warm-up thing, okay? This is what the real math is, I shouldn't say math, real theory, okay, started to come. So anytime you have a curvature, as you can see here, the green line is the green line? Yeah. And the green line here, you have I'm sorry. In the green line here, first of all, that green line is representing here the path of motion, right? And that anytime I'm touching this is just moving. 1 second. Hopefully it won't be the case this time. So you see, assume there's an object, a person or a rail or whatever, it's moving along the path, okay? When it is moving, it does have these two components of motion, okay, and ultimately the acceleration. One component will gonna go along the tangent direction, and another component will gonna go towards the normal direction. Now, where the normal direction will gonna go? Where the center at that point, okay? So if you have a means to find the center, from the center to that object, the radius of the curvature, they use the symbol rho for that, radius of curvature. Okay, I'll highlight that in the notes shortly. If you can find that value, then you should be able to find the normal component of the acceleration. Okay, I have the equations for there for this thing, and I don't want to go do the I don't want to go with the derivation for this, but I'll just simply show you the equation and application of these things. Okay, the description and everything is here. Please read through that for further info. Now, where you can find it again, because you don't have the access of the OneNote. Where you can find it? In Brightspace. I uploaded all the PPT. If you want me to show, I can show it to you. Not only this PPT, there are more also. Okay, whatever goes with your class lecture, you just follow, read through those. Others you can ignore. Okay, or you can read for more info. You got it? All right, so then the things get continue with this radius of curvature concept here. Remember the rho that I was talking, the radius of curvature. You will see that rho here. So rho, as you can see clearly, it can vary point to point, right? So depending on what point on the path, anytime you see a green line on the sketch, that represents what? The path of motion, right? So any time you are at any point on this green line, obviously both components AT and AN are going to change, right? So AT is straightforward, right? AT is like, the tangential component. That one is so straightforward, right? Everybody understand? So that's the AT. AT, T refers to what, Arlene? T refers to tangential, right? Tangential. You see those arrows that I'm putting for all those points here? So those are representing the tangential component of acceleration. Okay. So there is the other acceleration which is a normal. Normal one goes always with to the center. Now you may have, this is not a circle. Why you are getting the center? Obviously the center will gonna vary based on the point where you are talking, right? Right, you got it? So when you are here, this will be your center. When you are here, this will be your center. Okay. So at every point along the path, you should be finding the value of the rho. That rho is called radius or radius of curvature. Got it? This is the equation for that. Your job is to find the rho or radius of curvature to find the AN or normal component of the acceleration. Okay? The tangential component of the acceleration, I'm going to show you the equation as well. Once you have both of them, AN and AT, what are you going to do? You're going to use the Pythagorean, okay? To find the A, which is A equals square root of AN square plus AT square. Any questions so far with the theory? This would gonna feel like a little bit difficult, comprehensive at this point because you haven't done any math. Once you're gonna start to do the math, you're gonna get a good grasp on it. Okay, the math you're gonna implement everything that I'm saying and all the equations that I'm kind of pointing out here. Okay. All right, so so there's some more of the explanation here, but I'll gonna only focus here. Remember, that's the magnitude of the acceleration vector. Here, an is the normal component. So I'm trying to see. So this normal acceleration, okay? I'm trying to just highlight that. And at is what? Tangential acceleration, right? So this at is the most familiar acceleration that you used to use so far, right? Which is anytime you had acceleration, you do what? dv over dt, or what else you do? Depending on the direction, right? So if it's like in x, y, and z direction, then it could be written as so if this could be a vector, you have seen that, right? So d vx dt I, you have seen that in last class, right? I'm just writing the same thing again. d vy dt j, this d looks like a little bit small, so d vz, right? dt k. Now you remember the vx vy vz, everybody remember from last class? What are those? dx over dt, dy over dt, dz over dt. Ring a bell? And remember, we use this x I y j z k, right, to represent the r. And we remember the r that we used in last class. R is for the position vector, v is for the velocity vector, a is for the acceleration vector, right? So anyway, all those things that I did, these are for what? Tangential. Okay, let me highlight that. Tangential. This is for tangential acceleration. I am just doing a quick review so you can kind of connect what you've done so far. Tangential acceleration only, right? But the normal one is that something came here new, which is for what? Like the normal acceleration. Once you have both the components, tangential and normal, then you're going to use this Pythagorean, right? So Pythagorean, you see, if you have the tangential acceleration and if you have the normal acceleration, then to find the value of the or magnitude of the acceleration, right, you should be doing an square at square, right? So again, this n is for normal, this t is for tangential. All right, I'd like to end it here. Just wait a little bit. Two more examples here. So far, clear to everyone. Understood. Now, I haven't quite give you the equation for a and yet, right? A and there is an equation for that. Okay, it has something to do with the radius of the curvature. Okay, so there is an equation for radius of the curvature as well. Okay, and that one is not easy. So finding radius of curvature. Okay, before I jump into those two equations, again, try to focus on the big picture. Here we're trying to find the acceleration, which is two components of acceleration. One is the normal, another one is the tangent, right? The tangential one, up to last class, we had found it by using this equation. I wrote a bunch of equations already, right? You have used all of them, right? So the normal one, I said, which has something to do with, remember the centrifugal force, right? When something is moving on a curvature line, it will gonna feel some acceleration towards the center, right? So that's the normal one. That's the normal component. How to find it? So to find the normal acceleration component, you need to find the radius of curvature, rho. Radius of curvature is something similar to radius, right? Joe, so when it is like going this way, the radius is going to change constantly, right? Understand? So that's the challenge, finding the rho. Everything with me so far, right? All right, perfect. Now finding the rho, okay, and everything that I just said, yeah. Here's the equation for the normal. Here's the equation for the normal. Okay, let me write it. So normal acceleration. So again, everybody want to write this equation. Very important. Normal acceleration is again what? V square divided by rho. What is the rho here? Rho is the radius of curvature, right? Radius of curvature. Now radius of curvature is rho. What is the equation that you want to use to find the radius of the curvature? That's what I was telling, right? This is not easy, a little bit complex. Everybody see the highlighted one? That's the equation that I'm going to write here. Don't worry, you're going to have time to take all the notes. Just 1 second. So 1 plus dy dx square, square 3 by 2 second order derivative of dy dx square. So, which clearly tells you gotta know a lot of what? You gotta know a lot of derivative, right? The second order derivative that you gotta do, the first order derivative that you gotta do, okay? Dy with respect to dx. That's what you didn't do that much. What did you do usually? You did like dy with respect to dt, which is the vx, or you did what? Dx with respect to dt, which is vx, right? You did vx and vy up until last class. This is what you didn't do, right? I mean, we did it one time, I remember in one math, right? But bottom line, you gotta have to have a good grasp of the derivative, right? Which, don't worry, I'm gonna help you in that. But we have the math actually. If we have time, we can do that math. But I doubt that we will have time after the end stage. Okay. So take your time. That's it. That's pretty much it. Now, obviously, the tangential one, there's this equation for that, right? Do you see that? AT equal to V dot, right? You understand? So V dot is like, depending on if it's a x direction, so then it's like dx over dt is V, and dv over dt, dvx, let me put it this way, dvx over dt is a, right? That's the usual expression, the way we used to count. That's the AT. What is the AT again? Is it normal or tangential? Tangential. So let me write it here. So it's tangential acceleration. Okay, so you have the whole thing, which is AT equal V dot. Now you have seen what is V dot, right? Anytime you have a dot, that means velocity with respect to time, right? And again, it can be, if it's 2D, then you have x and y component. If it's 1D, just one component. If it's 3D, then you know the ballgame, right? Bottom line, this can be changed based on the direction. Anyway, I guess that's the whole summary on this thing, normal and tangential component. Are you doing good so far, theory? Any question? Anybody have any more? Anybody have any question? Everybody's good? Everybody's good? All right. So now it's time for us to talk about the homework. Let's see how you are doing with the homework. And it's some time. I mean, I'm seeing some of you are still writing. I'm sorry, the writing got a little bit distorted here and there. Finish your writing, okay? If you're still on the. Let me know. All right, I'm seeing nobody's writing anymore, so most likely everybody's done. So here is the homework 2 hints. First of all, this problem, you take it out, okay? I have some of the things written for you, but I guess I can take it out. So number 3, you don't have to do it, okay? If you did it, I'm going to give you a bonus point, but I don't want you to do number 3. I don't know if you realize this subject requires a lot of work. This is an extensive subject already. You started to realize, right? Maybe not. You will soon. I mean, these are so many common materials, like physics material already so far, but now things are getting a little complicated. Okay, the relative motion. I know you did in physics relative motion as well, right? You guys did relative motion, but maybe like in a not like this scale. Here you got to be a little bit comprehensive. Anyway, let's start with the first problem. Okay, let's see if you can give me some clue about the first problem. Let me get my class note as well. Just 1 second. Oh, did you guys notice I uploaded for homework 2, if I'm not mistaken. I uploaded some hints with all the description, like the steps For each problem, there is this much description. Okay, so anyway, that could be helpful. Please read through that. But I'll try to deal with some equations here today because the hints are already over there, which I won't be doing it again. The same thing. Here only I'm going to focus on the equation only. Okay. So anytime there's my suggestions for you. Okay. Anytime you see here a velocity, everybody's seeing it? I'm not seeing everybody's focusing. Aline, you are good? So we are doing the homework, okay? Question number 1. So you see what is happening? A baseball player, okay, just hit a ball, and the ball is following a projectile path, right? Good. All right. The ball is Aline, you are sick today? Any time? You're good? All right. So here the ball is following a projectile path, right? So what is happening here? You see the velocity, right? So the velocity and the angle, those two things are given. Anytime you are given those two, you immediately do what? Find the Vx and Vy. And these are initial velocities, right? You can put a subscript. So then it should be like Va, what? What would be the Vx component? Yep, perfect. Because the value is given 60. Let me even write it that way. So Va sine 60, right? So right away you want to do those two things, like these two different velocity in x and y direction. Okay. So that's done. So then it says here, okay, when the ball is directly overhead to the player of B, so there's this guy B, there's this guy at point B standing, and then he only will gonna run when he see the ball on the top of his head. Okay. All right. So then only he's gonna run. So that guy was initially 15 feet apart from the hitter. Okay. I never played baseball. What's this guy's called? Hitter? And this guy, what that guy's called? Fielder. Okay. So the fielder will gonna start run only when he see the ball on the top of his head, and the hitter is like, hitting that ball, and the ball is going to travel 15 feet. Okay. Now the question has several folds. First, it's asking you to find the value of the D, if I'm not mistaken. Yep. Right, the D. And then it's asking you, if I'm not mistaken, I did review last night, this velocity is asking you about this velocity. Okay. So finding the velocity is super easy. Once you find the D value, then you'll just simply add this 15 plus D, right? And then divide it by time, then you're going to find the velocity, okay? So that one is not that bad. The finding this, this D is kind of tricky, okay? So to find this D, let's deal with this. So to find this D, think this way. So the ball is traveling from here to here. How much of the total distance that it traveled? In x direction? 15 plus t, right? Perfect. And remember from last class knowledge, what happened from here to here? You got to understand from here to here, right? It's just as if like the same thing that way, right? So here to here, the ball start point is 0, y equal to 0, right? Y0 is 0. And here at this point, y is 0 as well, right? Remember, we use those two values in last class to do what? To find the time value. So this is going to give you the value of the time, which I don't know if you remember that equation. Y equal, I even forgot myself. Is it like y0 plus vy0 t plus half of at square? I hope I wrote the equation correctly. So if these two are not there, you know this, right? This t is unknown. You know this a as well. This is minus g, right? Can you find the value of the t? So that t value would be 2.15 seconds, okay? Once we're going to find that. Is good? All right. Once you find that, then what? You got to say like there are three parts of this problem. First part is like this. Second part is like this, right? Third part would be what? I'm still dealing with the first problem. So the third part would be, so if the ball travels horizontally, okay, and the catch point is x, then you can do this equation to find the value of the x, where that x value is 15, right? So you understand? Maybe not, right? Okay, let me give you a little bit more. So this 15 plus d is x. Why? Take a look here. This x equal to actually 15 plus d. Okay, so the ball, when it starts from this point, right? It has a x direction velocity is what? V x 0. You understand that? And at this point, the y distance is 0. You understand? Y0 is 0. When it finally hit the ground or catch by the other player, fielder, the y value is 0 again, right? So the time that you found, that's for the time for the ball to go from here to here, here to here. Is it clear? So if you're going to use this time here in this equation and this Vx0 here, what would be this x? Isn't it 15 plus d? Does it make sense? I don't want to go any further, but you should be able to finish the rest, okay? And there are the instruction as well, right? The hints. Please read through that. It should be helpful. Any question? Joe, you might have some question. You good? All right. So here's another thing. If you are asked to find the value of this h, can you do that? There's something to think about, okay? I don't think this question is asking that. But if they were going to ask you, just think about it. Ready for the second one? Okay, let me read through the problem a little bit. So it says, let me make it a little bigger, okay? How many of you started doing number 2 yet? Just 1, 2. Is it? Okay, everyone want to try it first, okay? Before I even start doing these hints, okay? That could be helpful, more helpful, okay? So a car is traveling along a straight portion of the road, has a velocity is indicated in the figure, okay? The figure does have the velocity, right? This 20, 30, and 40, right? These 3.3 velocities are given. ABC, obviously. It takes 3 seconds to go from A to B. There's the time given, 3 seconds. And then 5 seconds from B to C. So 3 seconds here, 5 seconds here. All right. Determine the average acceleration between point A to B and A to C. Okay, to acceleration you're going to find average acceleration. You know the acceleration equation is A equal v2 minus v1 divided by del t. All right. So what are those v's that we are talking? Then these v's does have 2 components, all of them, right? So that's where the challenge appears. Okay. You understand? But this is the equation that we'll be using. All right. Now, when I wrote those, like those are you can consider them in vector. Okay. Now for A to B, let's do that. A to B, what happened? You have this del t is 3 seconds, right? And A to C, your del t is what? Anyone? Is it 5 seconds?
No.
It's 8 seconds. Yes, thank you. So 5 plus 3, right? So 8 seconds. So you have these 2 different time, okay? That you will be using it in that equation for sure. Now here's the thing. You have these 2 velocities, like this VA and VV, has 2 components, X and Y components, right? So for VA, it's just 1 component, so it's fine. you can find the one component acceleration first, like the x component acceleration, right? By using Vax and Vvx. Okay. For Vv, you have like both Vvx and Vvy. You understand that? So let me write this. So you have this Vb is 30 meter per second, right? And this angle theta is 45. So if that's the case, then you can write Vvx is 30 what? Cos 45, and Vby, can anybody do the math? 15? 45 is root 3 over 2, right? 30 is 1/2. It should be different. 0.707, something like that. And anyway, it doesn't matter. You can do the math later, but I'm just giving you the directions, okay? This is the hints. So sine 45. So what your goal is to see, write this VB. First, you got to understand. So this 30 cos, let me write that. 30 cos 45 I, that's what your goal is to understand. 30 sine 45 j. You understand that? You see the results are given in terms of I and j. You see that, right? All right. Okay, so I mean A to C is very straightforward. That's why you have only I component. As you can see, at A you have only x direction, right? At C you have only x direction velocity, right? That's why you'll just simply use those. I mean, I can even do it like right away. So it will be 40 minus 20 divided by 8, right? So something in that nature, meter per second is squared. That should be your A to T, right? So that should be AC. And this whole thing would be I. And that's the answer, right? Understand that? A to C, but A to B where the things are a little bit different. Okay, so you gotta consider. So this BV, everybody understand that? I mean, if I'm gonna go any further, 1 more minute, I'm actually giving you all the solutions. But you know, VA, what is VA again, guys? VA is like 20 meter per second. Only I. You understand? So you gotta find the acceleration of the I component first. Okay. Again, for VV, you are seeing two components, I and j, right? For VA, you have just one component, I. So when you're going to find the acceleration for I component only, you're going to pick this component and this component. You're going to use them in this equation, right? Velocity difference divided by del t. What is this del t? 3 seconds. Understand? That's for the x component or I component velocity. Same thing can be done for the y. There's no y here, right? You don't have any subtracted value here. You just divide that thing by 3 seconds. That should be your y, right? Hopefully you understand. Everyone understand? That's problem number 2. I'm going to solve another problem. Just one more, okay? It doesn't make that much of sense to deal with all 8 problems, right? Number 3 you don't have to do. So like there is like what, 5 more left. Out of 5 more, now it comes to those who actually tried before. Just give me a problem which you want me to solve. The third one.
4.
Number 4?
Yeah.
Okay. Number 4 it is. Let me get my class note. All right. So this problem, it says, when a rocket reaches an altitude of 40 meters, it begins to travel along the parabolic path. Okay, so the rocket initially goes up, right? Straight to 40 meters, and when it comes here, it follows this trend. Like the equation is y minus 40 square equal 160x. So they gave a equation. Y is a function of x. Okay. Where the coordinates are measured in meter, so it's good. This is an SI problem. If the component of velocity in the vertical direction is constant at Vy equal 180 meter per second. Okay. So here they said like the component of the velocity in vertical direction is constant. So Vy value is constant here when it is moving up, which is 180 meter per second. All right. So determine the magnitude of the rocket velocity and acceleration when it reaches the altitude of 80 meter. So from here to here, say like this is 80 meter. So they are asking the rocket velocity and the acceleration. Okay. From here to here, so like it's point number 1, this is point number 2, this is point number 3. So 1 to 2, it just have one directional motion, straight up. Okay, everybody understood the problem? Understood the problem, right? All right, perfect. All right, so the path, let me start giving you some hints here. So the path y minus 40 square equal 160x. Now you're going to differentiate with respect to time to relate Vx or Vy relationship. So your goal should be finding a relationship where you have this Vx is a function of Vy. Why? Because take a look here. Is the Vy is given? And they said it's constant, right? So if you can find the relationship, right, Joe, we can do the difference. That's the difficult part, doing the derivative to find the relationship of Vx and Vy, right? So they gave you a relationship of y and x. So if you can do the derivative in both sides and find the relationship of Vx and Vy, you know the Vy. Can you find the value of the Vx? Again, what I'm saying is like, if you have a relationship, say like Vx equal to 2 Vy, zoo, hypothetical, right? You're good. Say like you're finding a relationship Vx and Vy. You know Vx and Vy, right? The velocity in x and y direction. You say like you found it. Say like Vx equal to 2 Vy. The Vy value is given, right? What is 180 or something? It's constant, right? So you can find the Vx. It is good on that. So you understand your motivation why you wanna do the derivative of this equation. If you're gonna do the derivative of this equation with respect to time t, wherever you have y, you're gonna have dy over dt, right? That becomes Vy. You understand that? Wherever you have x, that becomes dx over dt, that becomes Vx, right? So that's how we're gonna, and that is, I'm not saying it's easy to do the derivative of this equation. You need clear knowledge of derivative. And that's why it comes. I think you understand, remember, this derivative is a little bit tricky, okay? That's why I kept saying in this class, you gotta get a math tutor. You gotta get a math tutor if you are not too good at this derivative, okay? Because you need to know the derivative to find the relationship between those two, okay? Anyway, so let me help you a little bit with the derivative. I know you guys probably need some help, okay? So you are doing the derivative in both sides, okay, first of all, and you should be finding some value of, so you are doing the derivative in both sides means different, with respect to time, yep. So you are doing the, let me write it. So you are doing the differentiation, right? With, let me write that, with respect to time. And your goal is to find the Vx and Vy relation. Okay, hopefully you understand, right? So if you're going to do the derivative of this, like, with respect to dt, you understand that, right? I'm doing in both sides, right? With respect to dt, you kind of understand what I'm doing. All right, so on the right side, it's so easy. In the right side, what you're going to have? 160 in the right side. I'm sorry, it's a little congested. It doesn't look like 1 here. There's a 1 here. So it should be 160 dx over dt, right? That's what the right side is. In the left side, what you're going to have? In the left side, you're going to have 2 multiplied y minus 40. That's a little tricky. Okay, and that part of the differentiation, if I'm going to start explaining, it's going to take an hour. Okay, but please go back. Okay, so this whole thing can be considered as some variable. Okay, so like, I don't know, maybe a, something like that, and then you're going to derivative like dA over dt multiplied what? Remember that? Yeah. So like, so you'd be doing like, just 1 second. You'll be doing dA dy multiplied dy dt. I don't know if you recall. So what I'm doing here, don't want to confuse you with the A. I'm assuming, this is the first part. Again, that's the note. I'm assuming what? A equal y minus 40. Do you guys agree with me? Can I do that? Does it ring a bell from the math class?
Yep.
Math class, they should teach you for sure, right? There's no way around. So if you understand that, what is happening? See, actually, you have this this A. I did a mistake. It should be A equal this y minus the whole thing. Okay. So when you are doing this dA over dy, you have y minus 40 whole thing square. Can I write this whole thing as 2y minus 40? Can I do that? And this whole thing is note. Okay. So if that's the case, and can I write dy over dt? What is dy over dt? Is it vy? Is the same as vy? Logan, you get it? So it should be vy here. Can I write that this way? So this part again, the thing that I just did, that requires a lot of practice in calc class, and we are expecting you know up to this. If you are struggling, what I just did, two-way, just come talk with me in class. In my office. I'll try to help my best. Okay. If you don't have time, just go get a tutor from our library. It's free for you. Okay. Either way, you gotta understand that. Okay. Anyway, so once you have that, can I write this 160 Vx? Is the same thing. So 2y minus 40 Vy. So then, can I write this whole thing in terms of Vy? So can I write this whole thing in terms of Vy and Vx? So you're going to have Vx is equal to multiplied y minus 40 Vy. The whole thing is divided by 160. Can I write that? Let me know you're good. Understand? All right. So then what do you want to do? You want to do, remember, what you want to do? You're going to find the velocity and acceleration from 2 to 3. So at 2, the height is 40. At 3, the height is 80. So you're good? All right. So then at y equal 80 meter, okay, you have y minus 40 equal 40 meter, right? And Vy is 180 meter per second. Why I'm doing that? This 40 meter, you're going to plug it here, right? This Vy, you're going to plug it here, right? So you're going to find the value of Vx, which would be 90 meter per second. It was good so far? All right. Once you have those V's, then you can find the V magnitude of the velocity V, right? You can put a sign like this or magnitude. So then you will have Vx square Pythagorean, right? Vy square. Is good? All right, so that's the V. What about A? A is a little tricky. In the velocity in y direction, is it changing?
No.
What is the value of that? 160. So if the velocity in y direction of the acceleration will be 0, right? If the velocity in y direction is not changing, constant velocity. What's the definition of the acceleration? It's change of the velocity. In y direction, if the velocity is not changing, it's constant, there is no acceleration in y direction, right? So ay should be 0. What would be the value of the ax? Now you need to know the vx at 40, vx at 80, right? Once you have those, you find the should be right. So that's for the clue. That's for the hints for the acceleration. I mean, I kind of solved the whole problem except the acceleration, right? So this again, the acceleration ay should be 0. You just have to find ax, right? Which, by the way, the value should be 405 meter per second square. Okay. All right. I don't even have enough time, and I knew I couldn't have time. If I'm gonna go a little detailed because this problem is extensive, okay? There's no way I can do any more problem other than the homework games. Okay, that's fine. I want everybody to do the homework by yourself. Problem number 3 is not there. 4 more problems that you're gonna do. Try your best. Okay, we'll try to look at the solution. There are hints. You just have to work a little bit more. Okay, the descriptive hints are there for you in Brightspace. Okay, didn't you know that I uploaded another file for hints? Okay, okay. All right, and I'll upload this video lecture. Okay, for your reference. And I'm gonna grade your submission already.